Level, guys. Okay, so we're going to continue from question 11 to question 15. And let's just get right into it. Skaters of masses 80 kilograms and 40 kilograms move directly towards each other and collide. So I know it's something to do with collisions, which means momentum is involved, where we need mass and velocity. I'm going to keep reading and then draw a diagram once I'm done reading. In this case, I've already drawn it ahead of time, but during the exam, I would read the entire question and then draw and then recheck whether or not I've drawn all the information that I have. Before the collision, the heavier skater, which is basically the 80 kilogram skater, is moving to the right at a speed of this 2 meters per second. So they've given us direction and magnitude, so we can consider it as velocity. So we have mass and velocity. And the lighter skater is moving to the left at a speed of 1 meter per second. After the collision, the heavier skater moves to the right. After the collision, moves to the right, heavier skater. A lot of things to note and draw here. With a speed of 0.8 meter per second. What is the relative speed of separation? Which means, since we have the word separation here, we know that the objects are moving away from each other after the collision. So initially they're moving towards each other before the collision. I've drawn out exactly what they've given us, nothing extra. And after the collision, the heavier skater moving to the right with a speed of 0.8. And since it's a relative speed of separation, we know that the 40 kilogram skater is moving away from the other skater because it's relative speed of separation. They're separating. But one thing they have not given us, or we have to include, is the sign of the velocity. If we take the right side as being positive, then the left side will be negative, and vice versa. If you took this as positive, then this would be negative. So, right side, I'm taking the right side as positive currently. This is an important step that most people will forget. And this is why you might sometimes get the wrong answer. So if you make like a framework, like, okay, I need to have mass, I need to have velocity, and I need to have the sign, negative or positive, for each velocity, then you'll automatically not go wrong in this step. So since I'm taking right as positive, this, since it's moving towards the right, this will also be positive. So there's no negative sign here, right? Now, to find relative speed of separation, I need to first find this speed. Let's call it speed x, okay? To find speed x, what I'll do is, I'll use the principle of conservation of momentum, which is total momentum before collision is equal to total momentum after collision. Now, the reason I'm using this is because I know the velocities and masses of both objects in the before collision section. And there's only one variable I need to find in the after collision section, right? So if we do it like that, then we'll have to find the momentum of this heavier skater, which is 80, which is mass times velocity, which is 80 times 2, which is 160. So this is 106, has a momentum of 160. And this will have a momentum of 40 times minus 1, which is minus 40. So the total momentum before collision will be 160 minus 40. 160 minus 40 is 120. Okay, that is the momentum. And momentum before collision. So now momentum after collision should also be 120. So for it to be 120, let's first figure out the heavier skater's momentum after collision. 80 times 0.8, which is 64. So to get 120 from 64, we have to add 56, because 120 minus 64 is 56. So 64 plus 56 will give us 120. But 40 times x should give us 56. So basically, we'll have to figure out x, we'll have to divide 56 by 40. So x is 1.4. X is 1.4 meter per second. If you didn't understand that, if you just write this as an equation, that will also work just fine. If I went a little too fast, you can pause the video and try equating it on your own. It's just solving for a variable. Or you can replay this section of the video to understand. Now, to calculate relative speed, what we're going to do is, since they're both moving in the same direction, as this object moves with a particular speed, which is actually greater than 0.8, it's going to take time for this object to catch up. So the relative speed will actually be 1.4 minus 0.8. If you don't understand this concept, I will be making a concept-wise video very soon where I'll explain relative speeds in detail. Basically, let me give you another scenario. If two objects are moving towards each other, then it's going to be easier for it to collide, right? Because they're moving towards each other. If they're moving away from each other, it's going to be more difficult for it to collide. Remember it like that for now. When it's more difficult for it to collide, you're basically going to separate the speeds to show that it's more difficult. When they're moving towards each other, since it's easier, you're going to add up the speeds. For now, just remember it like that. So 1.4 minus 0.8 is 0.6. So the relative speed of separation is equal to 0.6, which is meter per second, which is option A. There's no real way to eliminate these options. We'll just have to solve the entire thing. Next, which statement describes two forces in a couple? When it comes to a couple, this is the only diagram you need to remember to understand what a couple is or remember what a couple is. So the two main points that you have to keep in mind when you look at this diagram is that the forces are equal in magnitude and that the forces are in opposite directions. So this is going to produce, if you don't understand this, if you use a pen and you sort of give two forces in opposite directions, right, with your hands, so just take a pen, view it from the top, place one hand here and move it in this direction, and place the opposite hand here and try moving it in this direction, which you're basically producing a couple, and you'll understand sort of how or in which direction it's going to turn. In this case, it's going to turn in this direction. If this were opposite meaning if this were this way and this were this way, then it would rotate in the opposite direction. So a couple basically makes it rotate. It gives you a momentum in a clockwise or anti-clockwise direction, a rotational momentum. Okay, so that's important to understand. Now let's go through the options that they've given us, and we can most likely eliminate. They act in the same direction. Clearly, no, they have to act in opposite directions. They act through the same point. No, there are two different points. They're on opposite sides. And to calculate torque of a moment, we'll multiply the distance between these two forces and one of the forces. So F times D will give you the torque of this. No, they produce zero resultant force. Yes, since the forces are equal in magnitude and act in opposite directions, they will cancel out, giving you zero resultant force. But let's just check with the last option. They produce zero resultant moment. That is not true. They produce a moment in either a clockwise or anti-clockwise direction, as you've seen earlier. So the option is C. Next. 13. A street lamp is fixed to a wall by a metal rod and a cable. The first thing you have to sort of understand here is the direction in which the forces are acting. Okay. So let's see which direction the forces act. First of all, we know that the weight of the lamp is definitely a force, the only force that's going to be acting here. Okay. Now let's see what they're asking for. Which vector triangle could represent the forces acting on the rod at the point P? So we're going to assume that this whole thing is going to be in equilibrium. So the lamp is stable and none of this is falling off, right? That's what it means by equilibrium. And so in that case, let's see which direction the force at the cable is going to act. So if you ever get confused, just remember from the weight or from the load of the cable is going to act towards where it's fixed or pinned. The point of contact is basically the place that it's fixed at. So this is the direction it's going to be acting in. Again, if you guys have any clarifications or if you want to go in questions in more detail or less detail compared to the videos I'm currently making, let me know in the comment section. I would love to keep improving. Currently, I'm not exactly sure how much detail I should give. So yeah, let me know that. So basically, if we assume that all the forces are acting in equilibrium, you should be able to sort of draw through a circle. Let me explain what I mean by that as we work through this question. First of all, we know that the only vertical force, so in the metal rod, you could either have a force acting this way or a force acting this way, right? So it's a horizontal force. The direction of the horizontal force doesn't really have to matter. As long as you know two directions out of three forces, that's more than enough. So first of all, the only vertical force acting here is the weight. The weight always acts downwards. We know the direction of weight. So these two are already cancelled out because the vertical force is acting upwards. So, and since the only vertical force is weight, which must act downwards, those two are cancelled out. So now when it comes to these two, we can use the idea of it going in a circle. So a circle basically meaning all forces are joined head to tail. So this is head to tail. So you can connect it like this, head to tail. Makes sense. And then this is also head to tail. This is again head to tail. So it creates one full loop. Whereas when you come to this option B, you've clearly got head to tail. Then you've got a head here, but you have head to head. Two heads are sort of meeting at this point. This is one way to do it, or another way is you know that the direction of the cable is sort of upwards. It's not downwards like this, it's going upwards, right? So since it's going upwards, this is the only option that you have. Going upwards. This one is going downwards. So you can see the differences in the options that you have remaining after you cancel out these two. And then you can work your way. You can say, oh, okay, so the cable directions are opposite. So which is the correct cable direction? The upward one. Or you could go with this whole circle idea, creating a full loop. That's also another way to do it. Okay, next comes the 14th question. Okay, an unknown mass and a 1 kilogram mass are fixed at opposite ends of a bar. The bar has negligible mass and a length of 30 centimeter. The bar balances when supported by a pivot placed 20 centimeter from the unknown masses as shown. So they've shown everything in the diagram is what I'm assuming. Let's check. 30 centimeter length, 20 centimeter. I see a 30 in the diagram. I see a 20 in the diagram. So data-wise, they've shown everything in the diagram. And since they've said an unknown mass, I'm pretty much assuming that they're going to ask about the unknown mass or what the unknown mass is. So something about the unknown mass. And in this case, they're asking what is the unknown mass? They want the mass. And here we have the 1 kg. Quite simple. Even if you take a pen, what I always like to do is when I come across these equilibrium style questions, I know I have to use clockwise and anti-clockwise moments. And since here the pivot is already given, we don't have to assume a particular thing as a pivot. I just take my pen, make my finger a pivot or something a pivot, and apply a force here with my finger with my other hand, and then see which direction it's flowing in, going in, rotating in. So in this, when you apply this force in this direction, it's going to move this way. This way is anti-clockwise. So we know that the force on this side is going to be anti-clockwise. And actually, if you kind of play around with this whole pen thing, you'll understand a few different situations. I don't know if I spoke about this in my previous videos, but I spoke about it in my tips video, which I don't think is out yet. So you can go through, you can use your pen and look at different scenarios. So one is the current scenario we're dealing with, the pivot in a particular place and two forces on opposite sides. Then which direction each force is rotating in. And then there's a pivot on one side and then two forces acting in the same direction. Then, as you can guess, another scenario would be one in this direction and one upwards. So like this, you can play around with a few different scenarios so that immediately once you look at this, you'll know, okay, this side's going to be anti-clockwise and this side's going to be clockwise, or they're both going to be opposite direction moments. So then you can just equate it. You don't even have to think which one's anti-clockwise and which one's clockwise, right? So in this case, this is the anti-clockwise moment and this is the clockwise moment. So the unknown mass is anti-clockwise, this is clockwise. So to calculate clockwise moment or any sort of moment, you're going to do force times distance from pivot, perpendicular distance from pivot. So in this case, I always suggest always write the distance or any unknowns that you have. So in this case, write the distance between the force and the pivot, which is 10 centimeters. So immediately when you come to having to calculate clockwise moment, force is 1 kg. So we need the weight of this for the force. So times 9.81. I also highly suggest you remember the formulas and data that they've given in the first pages of the sheet so that it saves some time instead of having to flip to the front to do this. Times 10, it's given in centimeter. Although I don't have to convert it because both are given in centimeter, both these distances are in centimeter, I'm still going to convert it to be on the safe side, because you never know when, like it's difficult to figure out when you need to convert and when you don't. So, and it's a simple matter of power minus 2. Once I calculate this completely, let me put it into my calculator. Times 10 times 10 to the power minus 2. I get 0.981 as my moment. Now let's look at the anti-clockwise moment. So we'll have unknown mass, let's call it M, times 9.81 to get the weight, since we need the mass, not the weight, times distance is 20, converted to meter there as well. Always remember, you have to convert, if you're converting it on one side, you have to convert it on the other side as well. So don't forget that part. Then if we pop this into the calculator, 1.81 times 20 times 10 to the power minus 2, we get 1.962 M. So now quite easily we can calculate M. Since these two are equal, it'll basically be 0.981 divided by 1.962. I'm just going to directly insert that into my calculator. I mean, in the exam, I highly suggest you to write it down on paper so that when you check for calculator errors, you can figure it out. And mind you, this M is going to be in an SI unit. So you will, if you solve this, you'll get M equals 0.5. But don't forget, this is in SI unit. So everything you do, just remember it's in SI unit. So to convert that to gram, it's times 10 times 1000 or times 10 to the power 3, which is going to give you 500 grams, which is option B. Okay, one more question left. A block of wood, density rho W, so that's the wood, I've already marked that here, has side lengths of A, they've already given that in the diagram. The block is immersed in liquid of density rho L, I've marked that this is rho L. Top surface of the block is at a depth of H below the surface of the liquid. They've already marked that here. Now, the acceleration of free fall is G. What is the upthrust acting on the block from the liquid? So if you want to calculate the upthrust acting on the block from the surrounding liquid, the formula for upthrust is rho, this is not P, this is actually rho GV, where rho is always the density of the liquid and V is the volume of the block. So that's important to remember when it comes to this formula. It's the only tricky part actually. So anywhere where we have a rho of the block instead of the rho of the liquid, we can cancel that out, which unfortunately is just one option. But no need to fear. We know another part, that the volume has to be the volume of the block, not the volume of anything else. The volume of the block, since it's a cuboid, since it's a cube, will be the volume of the cube. To calculate volume of the cube, you do length into breadth into height, or side cube, which is A cubed. So rho L A cube G. This is correct, but let's just make sure we can eliminate the other option. So rho L H G, not going to give you the volume of the block, out. Rho L A G, again, not going to give you the volume of the block. So option A is the correct answer. Now let's check our answers against the mark scheme. 1 minute. Okay, so 15, I'm gonna mark from 15 to 11. So 15A, that's correct. Then 14B, that's right. 13 should be D. Yes, 13D, correct. 12C, correct. And 11A, so that's correct. There we go. Thank you guys so much for watching. Don't forget to like and subscribe and comment down feedback for this channel and any other questions. Again, like I said, if you want any questions in detail, etc., etc., the next video is going to come soon. So stay tuned. See you later, people.